Overhead camshaft, commonly abbreviated to OHC, is a valvetrain configuration which places the camshaft of an internal combustion engine of the reciprocating type within the cylinder heads and drives the valves or lifters in a more direct manner compared to overhead valves and pushrods. Overview: compared to OHV pushrod systems with the same number of valves, the reciprocating components of the OHC system are fewer and have a lower overall mass. Though the system that drives the camshafts may be more complex, most engine manufacturers accept that added complexity is a trade-off for better engine performance and greater design flexibility. The fundamental reason for the OHC valvetrain is that it offers an increase in the engine's ability to exchange induction and exhaust gases. Another performance advantage is gained as a result of the better optimized port configurations made possible with overhead camshaft designs. With no intrusive pushrods, the overhead camshaft cylinder head design can use straighter ports of more advantageous cross-section and length. The OHC design allows for higher engine speeds, which in turn will increase power output for a given torque. The OHC valvetrain system may be driven by the crankshaft using the same methods as an OHV system, but in practice, lighter weight and maintenance-free methods are more commonly used. These methods include using a rubber Kevlar tooth timing belt, duplex or single-row roller chains, or in less common cases, gears. Early Ducati motorcycle engines used shafts with bevel gears to drive the camshafts in their OHC engines. In conjunction with multiple valves per cylinder, many OHC engines today employ variable valve timing to improve efficiency and power. OHC also inherently allows for greater engine speeds over comparable cam and block designs, as a result of having lower valvetrain mass. Fundamental types of OHC: there are two fundamental types of overhead camshaft layout, single overhead camshaft, and double overhead camshaft. Single overhead camshaft. Single overhead camshaft is a design in which one camshaft is placed within the cylinder head. In an inline engine, this means there is one camshaft in the head, whilst in an engine with more than one cylinder head, such as a V engine or a horizontally opposed engine there are two camshafts, one per cylinder bank. In the SOHC design, the camshaft operates the valves directly, traditionally via a bucket tappet, or via an intermediary rocker arm. SOHC cylinder heads are generally less expensive to manufacture than DOHC cylinder heads. Timing belt replacement can be easier since there are fewer camshaft drive sprockets that need to be aligned during the replacement procedure. In the early era of the liquid-cooled aircraft engine field, single overhead camshaft format engines were in existence during the First World War, for both the Allies and the Central Powers. The Hispano-Suiza a V8 engine, designed by Mark Burkig in the Allied camp, and the series of Mercedes inline six aviation engines, culminating in the Mercedes D for the German Empire, both used rotary shaft-driven single overhead camshaft valvetrain systems, and were among the most prominent aviation power plants of the First World War era. The late-war Liberty L-12 a V12 engine configuration American aviation engine also used the General Mercedes D-Series single overhead camshaft design, based primarily on the later DI's drive system from rocker box to valvestem. SOHC designs offer reduced complexity compared to overhead valve designs when used for multi-valve cylinder heads, in which each cylinder has more than two valves. An example of an SOHC design using shim and bucket valve adjustment was the engine installed in the Hillman Imp. A small, early 1960s two-door saloon car with a rear-mounted aluminium alloy engine based on the Coventry Climax FWMA race engines. Exhaust and inlet manifolds were both on the same side of the engine block. This did, however, offer excellent access to the spark plugs. In the early 1980s, Toyota and Volkswagen Group also used a directly actuated, SOHC parallel valve configuration with two valves for each cylinder. The Toyota system used hydraulic tappets, while the Volkswagen system used bucket tappets with shims for valve clearance adjustment. Of all valvetrain systems, this is the least complex configuration possible. Double overhead camshaft. A double overhead camshaft valvetrain layout is characterized by two camshafts located within the cylinder head, one operating the intake valves and one operating the exhaust valves. This design reduces valvetrain inertia more than a SOHC engine, since the rocker arms are reduced in size or eliminated. A DOHC design permits a wider angle between intake and exhaust valves than SOHC engines. This can allow for a less restricted airflow at higher engine speeds. DOHC with a multi-valve design also allows for the optimum placement of the spark plug, which in turn, improves combustion efficiency. Engines which have more than one bank of cylinders with two camshafts in total remain SOHC. Unless each cylinder bank has two camshafts these latter are DOHC, and are often known as quad cam. The term twin cam is imprecise, but will normally refer to a DOHC engine. Some manufacturers use a SOHC in a multi-valve design. Also, not all DOHC engines are multi-valve engines. DOHC cylinder heads existed before multi-valve cylinder heads appeared in the 1980s. Today, however, DOHC is sometimes confused with multi-valve heads, since almost all modern DOHC engines have between 3 and 5 valves per cylinder, but multi-valve and DOHC are separate distinctions. History. The first car to utilize an engine with an overhead camshaft was the Marr Auto car designed by Michigan native Walter Lorenzo Marr in 1903. The first DOHC car was the 1912 Peugeot, which won the French Grand Prix at Dieppe that year. This car was powered by a straight four-engine designed by Ernest Henry under the guidance of the technically knowledgeable racing drivers Paul Zuccarelli and Georges Boilot. Boilot, who drove the winning car that year, won the French Grand Prix for Peugeot again in 1913 but was beaten in 1914 by the SOHC Mercedes of Christian Lautenschläger. Among the early pioneers of DOHC were Isotta Fraschini's Giustino Cattaneo, Austro-Daimler's Ferdinand Porsche, Stephen Tomczak. Sunbeam built small numbers of racing models between 1921 and 1923 and introduced one of the world's first production twin cams in 1924, the Sunbeam 3-litre Super Sports, an example of which came second at Le Mans in 1925. The first DOHC engines were either 2 or 4 valve per cylinder racing car designs from companies like Fiat, Peugeot Grand Prix, Alfa Romeo Grand Prix and 6C, Maserati Type 26, Bugatti Type 51, and 3 years later, Harry A. Miller and Fred Offenhauser inaugurated the line of 4.1-litre DOHC Offenhauser inline for American auto racing engines, which began to dominate American open-wheel auto racing through much of the 20th century. American luxury automaker Duesenberg was an early proponent of overhead camshaft engines with their SOHC Straight 8 Model A, produced from 1921 to 1927. This engine had 4 valves per cylinder. Duesenberg also produced successful OHC race car engines in the 1920s. The Duesenberg Model J, 1928 to 1937, featured a massive DOHC Straight 8 engine producing 265 horsepower. Low-priced American manufacturer Crossley used a small, 44-SI 4-cylinder SOHC engine following World War II. This unusual engine was developed during the war by Lloyd Taylor, licensed by Crossley, and used to power generators and other military applications. The overhead camshaft was driven by a tower shaft and gears. The original design was made of steel stampings, copper brazed together to form a strong and light block assembly. It was known as the Cobra engine and generated 26.5 horsepower in automotive form. Electrolysis and corrosion problems due to the bimetallic construction of the Crossley engine and the salt-based antifreeze then in common use led to a more traditional cast-iron block assembly version of the same engine in 1949. Used in Crossley's Hot Shot sports car, this small OHC engine won the first 12 hours of Sebring race in 1950. The Crossley OHC was popular in H-modified racing for its higher PM performance. After Crossley ceased automotive production, the engine was produced by several other companies for many years, finishing its life as the Barcat 55 outboard motor manufactured by Fisher Pierce, builders of the Boston Whaler boats. When DOHC technology was introduced in mainstream vehicles, it was common for it to be heavily advertised. While used at first in limited production in sports cars such as the 1925 Sunbeam 3-litre, Alfa Romeo is one of the twin cam's greatest proponents. 6C Sport, the first Alfa Romeo road car using a DOHC engine, was introduced in 1928. Ever since this, DOHC has been a trademark of most Alfa Romeo engines. Fiat was one of the first car companies to use belt-driven DOHC engines in some of their products in the mid-1960s. Jaguar's XK6 DOHC engine was displayed in the Jaguar XK120 at the London Motor Show in 1948, and used across the entire Jaguar range through the late 1940s, 1950 and 1960. By the late 1970s, Toyota was the best seller of DOHC engines. More than 2 overhead camshafts are not known to have been tried in a production engine. However, Moto Guzzi has designed a motorcycle engine with a triple overhead camshaft configuration, with the intake ports descending through the cylinder head to 2 central intake ports between 2 outside exhaust camshafts actuating one of 2 exhaust valves per cylinder each. In inline piston aero engines, DOHCs have been used for mini engines. The 1970 Napier Lion, for example, had them. See also, cam in block, camless, overhead valve, valvetrain, references.